Well, here we've got the EnviroVent air power test meter, and basically what this does, these clear tubes replicate the resistance in a typical fan installation. So if you've got a wall sleeve and a grill, you're going to get a bit of resistance, usually 10, 15, maybe 20 pascals. Well, the resistance in these tubes is around about 15 pascals, and inside the tubes we've got a clear plastic disc, as you can see. So as we apply air into the tubes, if the fan can overcome the resistance, it's going to push these discs up to the top. I'll just demonstrate what I mean. We'll turn on the dMEV, and it's now running. It's operating at around 6 litres per second. So if I put it on the first tube, you can see it'll just slowly lift the disc up. And there's the second tube, and there's the third tube. Alright. So as you can see, the dMEV quickly compensates itself using the centrifugal technology, the sensorless constant volume, which means an electrician can just set it to the right setting, screw it to the wall, and it's guaranteed to meet building regulations. If you compare that to a traditional fan, such as this axial fan, your basic own brand traditional fan, you put an anemometer on this fan, it will be doing at least 15 litres per second, because that's what it's got to be doing to meet building regulations. But that's in free air. If we put it onto the test rig, it does nothing. Nothing happening. So it's making a noise and using energy, but moving virtually no air. And that's why we've got 5 million properties in the UK with condensation and mould, because people think they're ventilating the properties, when in actual fact they're not. And we'll try a dMEV. This is a brand leader's dMEV. We'll switch it on. As you can hear it turning. It's an axial fan, so it's working hard to overcome the resistance. It's got constant volume technology in it. Again, we put it on the test rig. It's doing nothing. Doing nothing. And that's a brand leader's, market leader's dMEV. If I just leave that on there. So what happens if you put flexible ducting on it? Here's some flexible ducting. 15 metres in fact. You wouldn't think any fan could overcome that kind of resistance, would you? Well, if you put it on an axial fan like this, it's no chance. As you've seen, it can't even handle 10 or 15 pascals. But what if we put our dMEV on it with sensorless technology? Well, if I first of all connect my ductwork to the test rig, there we go. And then we take the other end and take my dMEV, to the other end. So it's now going to have to move the air down 15, oh it's working already, down 15 metres of duct. Quietly, effectively, just compensating for the resistance in this duct. It almost looks too easy. I'll tell you what else I'll do. Let's get this duct. And we'll wrap it round here. I'll take it round here. And back up. It's kind of a typical installation you might see from an electrician. And then we'll put the dMEV on again. And there it goes again. What if I even squash the duct? I'll put my foot on the duct down there and we'll squash it down. I've left about a 1-inch gap in the ductwork. So 15 metres of duct and a 1-inch gap. Let's see what happens. You can hear the fan slowly ramping up, compensating for it. And that can only be achieved if you've got a mini centrifugal fan and sensorless technology in an dMEV. And that's why it's the best fan on the market for new build.